response. Incident response is a process that takes place when our customers, operators have cybersecurity breaches or compromises or other issues that they need help with. And then Ericsson, as of course, vendor comes into play, and we can provide our expertise and on the technology and how they are deployed to the customers. And these were processes where I was often involved also. So in very early on, first steps of my career, I really realized that telecommunication network is a very essential, important part of a society. I realized that how badly things can go wrong if telecommunication networks are disrupted or if they are attacked into and try to steal information inside the telecommunication network. And I also learned that how powerful these networks are for the business and how they can be abused to actually get some economic benefits out in a rogue fashion. So I early on started to categorize the asset at stake in telecommunication networks in these following three categories. We saw criminals who were abusing the charging and billing systems of the network, maybe generating fake subscriptions and selling them in the dark market, or then trying to abuse the legacy protocols and maybe steal two-factor authentication tokens from text messages, SMS messages that were still used then. So trying to abuse the telecommunication network in different ways trying to benefit it in economical, in monetary terms. So we see that money is definitely a motivator for threat actors to attack telecommunication networks. The second important asset is information, because the telecommunication network includes information that is very interesting to certain threat actors. It has information about who you are, what kind of identifiers you have, who do you talk to, what do you say, what messages do you send, and most importantly, of course, because the telecommunication network is a mobile cellular network, so it needs to know where you are at any given time to be able to connect the services in your handset, in your UE, in your endpoint device, in your phone, basically. So the network needs to know your location. And we have seen throughout the years different attacks into the location information, into personal information, and even into the content information of what is happening inside the telecommunication networks. We know that VIPs have been spied. We know that whole populations have been tracked for different malicious or political motivations. So we know that the information in the telecommunication network is very interesting to many certain type of threat actors. But then I usually categorize the third category, and I say that that's the network itself. The existence of the network and the service to be up and running, that is also an asset, that disruption of which is very interesting to certain threat actors. If you think about it, you know, how many of us will be staying sane if internet is taken from us for 15 minutes or an hour or day or a week? So in the same way, the telecommunication network is actually one of the most important communication channels, if not the most important communication channels in any nation. And now if you think about it, if you want to disrupt a nation or a region for your political or other motivations, disrupting the communication channel and making people vary about what is happening and how they can get information is really powerful. We have, of course, seen that the networks have been disrupted just by disgruntled employees that have been jealous, or they have been fired and they have been angry, and because of poor operational security they have been able to cause havoc in the network. But there are more severe and more bad motivations or worse motivations behind also sometimes. But this kind of concludes that already for many, many years, telecommunication networks have been very important to be protected well, because these assets are attractive to threat actors and they are attacked on weekly basis, on daily basis, on monthly basis all the time. When we come to 2021 and we consider 5G and security and the new use cases, IoT and critical, mission critical and whatnot, then the picture gets even more complex. because already the text and voice was important to protect, your location was important to protect, but now we are also deploying to factories. We're deploying in mission critical use cases. We are deploying to cyber physical systems that are combining robots and big machinery and people into the same networks and actually creating immense efficiencies and growth opportunities to companies digitalizing themselves. At the same time, we are also digitalizing the critical society services. We are putting health data into networks and clouds and services. And I think that's an important aspect also, because if you think about a very common cyber breach is you're tricked over email or text message, you're tricked to click a link so that someone can steal your credit card information. They trick you on a fake page where you insert your credit card information and it gets stolen. Well, that's bad luck and really unfortunate. But you can always get a new credit card and you can always get new banking credentials, and you can even get money if you lose some. You can probably get money back from the credit card company or insurance or whatever. But what you can't get back is your health data. If you lose your health history, your complete life in digital format, and you lose it once, you can't get the new one. So it's very important to understand that when we're deploying these different use cases, we're actually having risks that we need to be addressing in a systematic, holistic manner. The same way the consumer IoT, all the wearables and devices and vehicles that we have around us are collecting data about us and our behavior, what do we do and what do we want to do. And that information at large is also an asset that is interesting to threat actors, but it also can be abused in multiple ways. So all these aspects are increasing the asset at stake that I described in the previous slide. So no wonder that regulators, countries, governments are really zooming into the 5G security. Everybody are realizing that this is a security issue, that we are getting all these connected devices, all these connected services, that companies that have never been used to be connected into the internet, now they're digitalizing themselves and finding efficiencies and growth areas in new ways. So how do we make sure that this is secure? So 5G has really got attention of the 2020s and the security in it. I really like these statements that we have exemplified here, like the one from Australia, where they say that the security and resilience of telecommunications infrastructure significantly affects the social and economic well-being of Australia, and is vital to the delivery and support of other critical infrastructure and services such as power, water, and health. It really shows that governments are understanding the connection between the 5G network and the critical infrastructure and critical services, really the base rock of our well-being in our societies. I think this exemplifies very much why we are having these discussions as of today, why 5G security is so important. But the picture is not as dark as it may sound, and especially coming from a security guy who mostly sees risks, threats, vulnerabilities, and other negative sounding things around us all the time. But that's my job also. But it's not that dark. In 5G already in release 15 a couple of years ago, we had massive improvements to the already pretty good security of 4G. So already in 4G, we had strong encryption, we had hardware root of trust, we have hardware digital identities and whatnot. But in 5G, we added subscriber authentication, enhanced subscriber privacy. These are things that are really making it much more harder to do fraud scenarios, execute fraud, conduct fraud in a case where subscriber is roaming internationally, or for example, much harder to snoop into the messaging because the subscriber identifiers are not broadcasted in the network like in some legacy generations have been. Service-based architecture, SBA, security and interconnect. Very important improvement of security overall, because we are now first time ever deploying these global networks on cloud native microservice-based architecture, where every service in the network actually have to authenticate mutually with each other. And this means that the network actually has already, from the specification, defense in depth. And almost like a zero trust type of a deployment, because if you get into from one corner as a threat actor, you get in from one corner, you can't move around and laterally move in the network like maybe in some legacy deployments you could have done. Integrity, protection of user plane, and protection of RAN and core network interface is very important improvements as well. And then if we want to understand how to actually make the deployed networks secure. So we are talking about the deployed networks. We are not talking about a lab scenario. We're not talking about the blueprint. We're actually talking about the real life operational deployed networks. So that work starts in the national standardization. So standardization in telecommunication world is the first place where we actually define the protocols, we make them secure, we decide on algorithms, but also like of course, in everything in telecommunications, interoperability of different functions in the network are agreed in the standardization. Secondly, comes the vendor product development process. And this is, of course, the process where I have most work to do as the Chief Product Security Officer of Ericsson, where we are actually defining what kind of internal regulation and requirements we have for how do you do security and privacy by design, how should you write secure code, what kind of components you can use, how you integrate them, how you produce your own code, and then how you test and assess it throughout the life cycle before you roll it to the customer, and how you guide customer and then help customer in case of a issue or incident happens. The third layer in the trust stack is deployment process. And this is where the operator is responsible for deciding who to buy their software and hardware from, and as well who integrates the network altogether. But this stage, they also specify the architecture and configuration of the network so that it is also secure in the end. Because it's always that you bring together products and components and software and hardware, and then you have to configure it securely so that all these puzzle pieces actually come together and make a good, living, solid, secure network. And the fourth layer, the outermost layer in the trust stack is the operations process. And this is the process that then starts when the network is specified, developed, and then deployed and configured, but then operated for years. And during this operation, it's of course, monitoring the health of the network, the performance of the network, but also the security of the network. There shouldn't be anomalies. You shouldn't have any unknown users logging in. You want to understand what happens there. When you do increase the capacity or add new features and functions, you may need to, for temporary purposes, lower the security to introduce the features and then again harden and launch the new services. And that is a continuous integration and continuous deployment of the network is also what has to remain secure over all times. But this also involves, of course, incident response and security operations center continuous monitoring of the technology so that threat actors are not getting benefits of your subscribers and your businesses that you're supporting. And I think that most importantly, we need to understand that we are here, all of us in this trust stack picture, we are here protecting the end user's experience of security and privacy in telecommunication networks. If we look at how then Ericsson is helping to make sure that we are providing secure technology, that we have secure specifications, and we are actually also deploying and operating or being able to provide deployment and operational security capabilities. Some of the examples here in very packed slide, you can read from the left to right, from the blue to green over the purple there. You see Ericsson research. We have security research globally, where we are actually researching new concepts on how to actually, what kind of threats will be in future facing telecommunication networks, and how can Ericsson try to mitigate those for the customer operators and the end users. Then we have the community influence. Of course, we are part of the standardization boards and bodies in all aspects of the 5G telecommunication network, as well as we are also participating security communities like FIRST and other communities where actually common ways of working in security are defined. We have our own security reliability model as well, and then we also provide, and when we go to the deployment side, we provide hardening guidelines and configuration deployment guidelines for operators to actually make sure that the secure products are then also deployed in a secure manner. You have professional services and PSER. I started my career, the product security incident response, that is also helping with the vulnerability management continuously and identifying when there are vulnerabilities in the technology that need to be patched, and then R&D delivering patches to those vulnerabilities. And then in the last phase, the operate, a lot of different capabilities. To name one is maybe Ericsson Security Manager, which is a result of our continuous lessons learned and learning in the telecom security. And we have identified that it's not at all simple to manage and orchestrate a living, a live network and deploy it and then orchestrate it in a live situation. So we created this a product called Ericsson Security Manager that is actually then automating those aspects of orchestration and automation of the configuration management, for example, but also provides detect and protect capabilities to the live network. And then, of course, you have services from Ericsson Managed Services, but also PSER and others who are providing intelligence and threat-based information about what is happening in the telecommunications world and what you should protect yourself from. This here is Ericsson Security Reliability Model, SRM, as we short it often when discussing internally. SRM is really our own model. It is a product of multiple years, more than 10 years of systematic work in security, where we started by making baseline security requirements and defining what is mandatory to do in first stages in early 2000s, when we wrote the first baseline security guidelines, was really that you need to do risk assessment, you need to do vulnerability assessment, you need to do all those activities before you launch your product. But then a little bit later, we actually bundled all of that under this SRM, Security Reliability Model, under that name and under that concept, and that you can see on the screen here. The most important parts are the four pillars that we have in SRM. It's the functions, about what you need to implement to have secure functions and security functions in your product, and then assurance, how do you test and make sure and assess that you don't introduce or inherit any security vulnerabilities from components and products that you may be using as part of your own product. And then also, of course, providing compliance and documentation to also help customers, the operators, to run the products as part of their network in secure manner, and then helping in deployment and operations to actually guide how the very sophisticated technology that telecommunication network consists of, the sophisticated technology of Ericsson, how that can be managed and operated in a secure manner. And on the above part of the picture, you see that there is this gray a line with few functions: supplier, source, develop, deliver, customer. This is our view of how the security has to be managed as a vendor of national critical infrastructure. It really starts that you understand your suppliers, who you buy from, what do you expect from them, what kind of requirements you set at them. You source securely, but then you also develop yourself. You have secure coding practices and testing practices, everything, but also into delivery, so that nothing goes wrong when the software is actually signed with Ericsson credentials and delivered to the customer network. So it's authenticated and actually identified as a legitimate Ericsson software when it's running in customer network. And then finally, in the customer's end also, we need to have the ability to support and provide guidance and operational help to our customers to actually make sure that the networks are secure in future as well. So Ericsson Security Reliability Model is really an end-to-end concept, and we don't forget security of our products until they are end of life. And as a summary, I would like to maybe state that in this picture, this is a simplified picture of some of the capabilities that an offering that Ericsson has for security. And these are really a result of decades of systematic work in security of telecommunications, from standardization to deployment and operations. We have defined Ericsson radio access network security solutions. We have integrated packet core firewall protecting from threats coming from other networks towards the customer network. And then we also have, for example, the unified signaling firewall. And in the bottom of the, or not the bottom of the picture, but in the middle of the picture, you see this overarching blue bar, Ericsson Security Manager, who's really bringing some intelligence, automation, and orchestration to the very complex world of telecommunication security. Many other functions there. My first home unit, product security incident response team, PCERT, mentioned there, also making sure that we always have spearhead competence, helping our customers when the cyber incident happens in a telecommunication network, that they can call Ericsson and receive help to resolve and come back to business from even the most unfortunate situations with cyber threats. And all of this, everything in the network is really following Ericsson security reliability model and being developed by Ericsson security champions and masters across all the units. So we have this ubiquitous competence where we have masters and security champions in every unit in Ericsson, making sure that every process part of the life cycle of a telecom network, of a 5G network, has security and privacy inbuilt into the process already from beginning. And if you want to learn more, you can always go to Ericsson.com. You will have our security site there, as well as you will, for example, have our guide for 5G network security, more information about security reliability model, as well as, for example, product security incident response team, and our responsible vulnerability disclosure policies also found there, and many other more forward-leaning and future-looking documents and white papers about security and what's going to happen today and tomorrow in the world of security of 5G and telecommunication. Thank you for your time. It was a pleasure. I really appreciate that you took the time to listen to me. I hope that you have enjoyed the whole event, and I wish you the best possible rest of the event, and take care and keep in touch. Thank you.
On behalf of CYDES, I wish to say thank you to everyone, to the audience that is listening, to Mr. Miko from Ericsson, and I have also put in his email address so that you can ask your questions in there. Thank you. See you next time.